Hi students, in this class we are going to discuss about the important questions given by the Telangana government in the booklet provided by them. We can download it from the internet, that is called Abhyasa Deepika. So in from this Abhyasa Deepika, today we'll be discussing the questions from the chapter Atomic Structure. Okay, so the different questions, I will read out each and every question and I will solve the answer related to the questions given in Abhyasa Deepika. Okay, so the first chapter which I am going to discuss is that is atomic structure. In that, the first question given is write the electronic configuration of chromium and sodium. Write the electronic configuration of chromium and sodium. So as we know, chromium, chromium chromium atomic number is 24. Okay, chromium atomic number is 24 and even one more was given, that is sodium. Symbol is Na and atomic number is 11. So the electronic configuration. So I hope you all studied about the different principles related to electronic configurations. We are having Gauss principle, Lorentz rule, Pauli's exclusion principles are there. So based on those principles, I'll be solving the answer for this chromium. So to make you understand very easily, I will be writing the Molar's diagram. According to Molar's diagram, we know that this is 1s, 2s, 3s, L value, L is equal to 0, s orbital, L is equal to 1, p orbital, L is equal to 2, d orbital, L is equal to 3, f orbital. So that is, here is 1s, 2s, 4s, 5s and so on you can write. And next L is equal to 1 means p orbital starts from second shell. That is 2p, 3p, 4p, 5p and so on. And L is equal to d orbital. D orbital starts from third shell, 3d, 4d, 5d. And in even if you don't have that, it starts from, that is fourth shell, 4f, 5f. And here you have to write the shell number, that is principal quantum number value. N is equal to, here it is, N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5. So if I draw this one, the Molar's diagram, first electron enters into 1s orbital, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s. Okay, in your textbook he has given the arrow and the head of this arrow is connected to the tail of the second next arrow which I have drawn. So you can join like this, but you can leave even like this also, no problem. But exam point of view, follow the textbook only. So chromium atomic number is 24. As the chromium atomic number is 24, it contains 24 electrons are there. So I will write the configuration. As you know, s orbital contains maximum 2 electrons, p maximum 6, d maximum is 10 electrons. No need to bother about fluorine. Okay, with Andreas point of view, you don't have any f orbital here, but f orbital contains maximum number of electrons is 14 in that. Okay, now 24 electrons are there of chromium. So first electron enters into 1s orbital. Configuration of chromium is 1s2. First, next is entering into 2s. S maximum electrons is 2, 2s2. Next is 2p. P maximum electrons is 2p. That is 2p6. 6 electrons are there. Maximum 2p. P 6 electrons. 2p6 is a. Next one is 3s2. Next is 3p6. Next is 4s2. Next one is up to here you count. 2 plus 2, 4 plus 6, 10, 12, 18, 20. How many left? That is 4. We can write 3d4. But this is not of a stable electronic configuration. This is not stable electronic configuration. To make the orbital more stable, okay, then orbitals with completely filled electrons and half-filled electrons are more stable. So to make this configuration more stable, then I can write this one as, instead of 4s2, 3d4, 4s2 half means 4s1, 3d, d maximum number of electrons is 10, half means 5, then I can write as 3d5. That is continuation 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5 is a perfect configuration for chromium. Okay, this is stable configuration. In some other way, in the old textbooks before 2013-14, okay, now we are having configuration. Sometimes in the books it is given as argon. Up to here is argon configuration. Argon 4s1, 3d, 5 was given. So this is a chromium configuration. Next configuration was given. I hope you all understood how to solve. The chromium atomic number is 24. It contains 24 electrons. We least bother about the protons here. We least bother about neutrons here. How many are there? But we need to think about electrons only. 24 electrons are there. We are going to distribute the electrons, arrange the electrons, or fill up the orbitals according to this particular Molus diagram. Okay, configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5 is a perfect configuration. If you write this, you'll be getting full marks. Please don't write this in the exam and don't write even this one in the exam. It's better to go with this one. That is up to here is argon configuration and 4s1, 3d5. So that is here is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5 is a configuration of a chromium. Next configuration of chromium, next element configuration was given is that is what right is a sodium. So I hope you understood this. Next electronic configuration what right is a sodium. Sodium atomic number is 11 and it contains 11 electrons. Sodium atomic number is 11. It contains 11 electrons. Configuration is, I am writing directly 1s2, 2s2. Configuration is 1s2, 2s2, 2p6, 3s1. So if you count the number of electrons, sodium atomic number 11, 11 electrons are there. 1s2, 2s2, 2p6, up to here is 10 plus 1, that is 11 electrons. This is sodium electronic configuration. Now the next question given in the government paper is, that is Abhyasa Deepika. We have next question is, write n plus L value for 5p and 4d orbitals. Now the next question is, write n plus L value for 5p and 4d orbitals. Next question is, write n plus L value for I'm writing for 4p and 5d orbitals. Okay. So for 4p orbital and 5d orbital, we are going to write n plus L value. 4p orbital. Okay. Now n plus L value. If you observe here, so I think you people remember this NLX method. So in NLX method, n is representing principal quantum number. L represents angular momentum quantum number or azimuthal quantum number. So n value is given as n is equal to 1, 2, 3. N is nothing but gives rise to shell number. N is equal to 1, 2, 3, 4, etc. L value represents type of subshell. L is equal to 1 means L is equal to 0. L value starts from 0. L is equal to 0 means subshell is S. L is equal to 1 means subshell is P. L is equal to 2 means subshell is D and so on like that. Okay, now we are going to write n plus L value for which orbital? 4p and 5d orbitals. Now we'll write n plus L value for this. N plus L value. If you count here, see n represents principal quantum number, n value starts from 1 is 1, 2, 3, 4, etc. Now here we have in front of p orbital we have 4 is the value. There is n value here is 4. And for 5d, n value is how much? 5 plus L value. Now what orbital was given here is p orbital. So if L value is equal to 1, then which orbital comes? P orbital. Then in place of, for n plus L value, in place of L, we can write the value of L here given is 1. That is 4 plus 1 is equal to how much? 5. Now next one is for d orbital. D orbital means L is equal to 2 is the value. If L is equal to 2 in angular momentum quantum number or azimuthal quantum number, okay, L value if it is 2 means which orbital? D orbital. So that is D orbital is there. Then we have to write the L value as a 2. That is how much? 4 plus 1, 5. 5 plus 2, 7. So the n plus L value for 4p orbital is 5. And for 5d orbital is, that is 5 plus 2 is equal to 7. Is it clear? I hope you all understood this explanation. Next one. The next question is, according to Abhyasa Deepika, explain line spectra. Okay. What is line spectra? When this line spectra is formed? Next question is explain line spectra. Okay, line spectra. When does this line spectra is formed? This is in atomic structure, we are having Bohr's model of hydrogen atom is there. So in the Bohr's model of hydrogen atom, I hope you all studied about Bohr's model of hydrogen atom. In that we have line spectra, band spectra are there. Okay, what is line spectra? For example, this is a nucleus. We know that this is the first shell, K shell. This is second shell, L shell, and this is M shell. Now, if I consider the energy level, this is a first shell is having energy E1, second L shell is having energy E2, for example, and is having E3. And if I take the values, n is equal to 1 year, 2 year, 3 year, n is equal to 1, 2, 3, n is equal to 1 means K shell, n is equal to 2 means L shell, n is equal to 3 means M shell. So, if an electron jumps from one energy level to another energy level, if an electron jumps from lower energy level to higher energy level, means first shell to second shell, energy will be absorbed. Okay, if an electron jumps from higher energy level to lower energy level, the electron jumps from higher energy level to lower energy level, energy will be emitted. So this line spectra, what is spectra? You should know the definition, basic definition. The discrete energetic lines, the discrete energy lines are called spectra. When does these discrete energy lines are formed? If an electron jumps from one energy level to another energy level, maybe it is from lower to higher energy level or higher to lower energy level. Okay, the energy higher to lower means energy will be emitted. Lower to higher means energy will be absorbed. So when it is jumping from one energy level to another energy level, the energy may be emitted in the form of radiation, okay, or absorbed in the form of radiation. This any emitted or absorbed energy is observed in the form of spectra. Okay, so here what is line spectra means? If an electron jumps from higher energy level means E2 energy level to E1 energy level, energy will be emitted in the form of radiation. This emitted, the electron jumps from this energy level to this energy level. So the energy will be emitted in the form of radiation. This emitted energy, okay, or radiated energy, which is coming out in the form of radiation, is observed in the form of discrete energetic lines. Okay, in the form of lines it is appearing. Hence the spectra is called as line spectra. Understood? It occurs when an electron transition takes place. It jumps from one energy level or one shell to another shell. Okay, so the line spectra is formed when an electron jumps from one energy level to another energy level, or from one shell to another shell. The energy so emitted in the form of radiation is observed in the form of discrete energetic lines called spectra, and this line spectra is formed when the energy is emitted. So this line spectra is observed as a bright lines at a dark background. Background is very dark. The background is very dark, and on this dark background bright lines are observed. Okay, this is what called as a line spectra. I hope everybody understood this explanation. Now, draw the shapes of p orbitals. The next question will be draw the shapes of p orbitals. You might be having some doubt. Okay, now draw the shapes of p orbitals. P orbital shapes. We are having p has got 3 degenerate orbitals. In p orbital, 3 degenerate orbitals are there. Okay, they are, the 3 degenerate orbitals are, that is px, py and pz. Sir, what is the meaning of that is degenerate orbitals? Okay, the orbitals having same energy. What are degenerate orbitals? It may come in a bit part also. Okay, the p orbital is having, you know that this is a dumbbell shape, having a dumbbell shape. And p orbital maximum number of electrons, 6 electrons. Okay, and the p orbital starts from second shell. It starts from second shell. And p orbital is having a 3 degenerate orbitals. As it starts from second shell, it is generally called as a 2px. Okay, next 2py and 2pz. 3 types of orbitals are there in the p. They are 2px, 2py and 2pz. These 3 are called degenerate orbitals, which comes under second shell. Okay, in third shell, if it is there, p orbital is there, means 3px, 3py, 3pz. fourth shell, 4px, 4py, 4pz like that. So there are three degenerate orbitals are there. So I am going to draw the shape of this px, py and pz. Now the px orbital. Now you may have some doubts, sir. We have to mention the dumbbell shape on the axis only, a particular, actually this is x-axis. According to mathematics point of view, talk about graphical point of view, graphs point of view, this is x-axis, this is y-axis and this is z-axis. Okay, so you have to draw the dumbbell shape on x-axis. This is x-axis. This is x-axis. Dumbbell shape is on x-axis. This is y and this is z. This is called px. This is called px. And the dumbbell shape falls on y-axis. This is y-axis. This is x and this is z. This is called py. Okay. Now, if the dumbbell shape is on z-axis, I am drawing the shape of that I will draw here. Okay, next one is, this is what called, this is x-axis, y-axis and here it is z-axis. If the dumbbell shape is on z-axis, it is called pz. As it starts from second shell, you can name this as 2px, 2py, 2pz or 3px, 3py, 3pz. Simply you can write as px, py and pz. There are three degenerate orbitals in P and those are these three types of P orbitals are three. They are px, py and pz. I hope you understood even this drawing also. Short answers will be covered in part 2. In part 1, you'll be getting very short answers. In part 2, you'll be getting short answers, even along with the bit part. Okay, thank you.